Welcome back, everyone. In this session, we are going to cover a rather advanced topic that is necessary for you to use CNC equipment at the center. So let's review where we are at. We have already made the Titan 1M part, but that is not sufficient for our process. I know most of you are familiar by now about the concept of subtractive manufacturing, meaning we start with a rough cube and we progressively cut away till we end up with our final product. However, this subtractive manufacturing happens in stages or steps, and we need to have models for every stage of the manufacturing process. So I'm going to go ahead and create those steps of completion, and I'll show you how you will create those steps of completion. So the first thing we'll need to do is we'll need to acquire a file from one of our shared resources. So for that, go to Home, navigate to Work Holdings and Stock, click on it, navigate to Parametric Models, Stock Prep, Flat, and we are going to go with cuboid flat. Which preparatory file you use is highly dependent on the process you're using and the type of stock you're using. So make sure to consult with the TA when you're actually doing this for a different part. I'm going to copy it. Make sure you always copy shared resources. You should never modify them directly. And I'm going to copy it to wherever I'm storing my files currently. So it just so happens to be under practice. And I'm going to copy it there. Then I'm going to go home and navigate back to the location where I'm storing the files. Okay. Now that I have the files, I'm going to open that file up and see what it does. So here we have a file where we have a simple block. This block represents a rough stock that does not have precision surfaces, and that stock is being transformed into this part right here, which has a shoulder cutout whose purpose is to ensure that we have precision surfaces to grab onto when we are doing aggressive cutting. So what I'm going to do is create another file. I'll save any changes here, Command save. And you see the changes are saved into my copy of the file and not on the main file. And I'm going to save this new file as steps of completion. Save. In steps of completion, we're going to learn about a new tool. This tool is called Insert Derive. Insert Derive should be used whenever you're trying to take a part, have a linked history, but you want to add to the history. Let me repeat that. This part right here has a history. If you play it, you can see it go through that history. I'm going to play it again. Apologies for that. So you see how it's going through its history. I want to maintain this history, but I want to add additional things to this history. That is when I would use Insert Derive. Now that might seem a little confusing right now, but as we go through the process, that will get cleared up. So I'm going to save this again. First thing I'm going to do is I'm going to switch to steps of completion and go for Insert Derive. Then I'm going to select the file from which I'm deriving, and I'm going to select cuboid stock and part, and I'm going to take these two components and bring them over. Now if you look, these two components aren't attached to each other. They're free floating. They're all free floating. So I'm just going to join one of them using the join command, which is used for assemblies, and click OK. So I can't physically move this, but I can still move this. So I'm going to join this again, here to here, and I'm going to move it across, and I'm going to click OK, and I'm going to click on Home again. So right now these two parts cannot be physically moved because they have been joined together with the axes. But I'm gonna now start creating some more parts. So I'm gonna click on Insert Derive and go to Titan 1M, and I'm going to get my part from here and click OK. Now it's hidden right there. If you have your part buried inside another part, you just need to hide the components, pull it out, and then you'll be able to see your component properly. So I'm going to also join this right here, flip it around, and I'm going to create some gap there. So I'm going to drag this all the way across, and I'm going to create a gap there. Okay, now the reason I've created a gap here is because there's an intermediate model that represents what the results are going to look like. So just follow along with the process, and once we get into CAM, this will make a lot more sense. So what I want you to do now is create a new component called intermediate. Once that component is created, make sure it's the active component, and within this active component, we are going to once again insert derive some pieces. So I'm going to insert derive from cuboid flat. When insert deriving, make sure you unselect pre-selected things and select the exact thing you want. In this case, we want this part. So now this part has been insert derived into intermediate. You can see it right here. And I'm going to insert derive the Titan 1M. Now it's auto selected the correct thing, but I'm going to reselect it. Click OK. And now I have Titan 1M and the part. While this is active, I'm going to make a few calculations. So the first thing I'm going to do is I'm going to find the height of this part. So I'm going to zoom in, press inspect, and it looks like this is 0.75 tall. That means that I need to take off at least 0.75 from here before I can use it. Now 0.75 would assume that the bottom of this surface is perfectly flat, and which it's not going to be. So I'm going to take off 0.8 instead of 0.75. So I'm going to come here. I'm going to activate the piece that I care about. So the colors help here. This is purple and this is also purple. Click on that. So now I have the right thing activated. I'm going to hit extrude. Cancel. I'm going to hit extrude, and I'm going to click on this surface, and I'm going to reduce 0.8 and click OK. So now this is 0.8 shorter. Now this is what I meant by when you want to add to the history. You see this icon here? This is referring to the fact that the history for this part here, this entire history, still exists, and I have just added an additional extrude to that history. That is exactly what insert derive is meant for. Now the next thing I'm going to do is I'm going to come out of this part and go to intermediate, and I'm going to hide the rest of the stuff since it's getting in the way. And I'm going to do a joint between this component and this component, and the orientation is correct. That's the orientation I want, and I'm going to click OK, and I'll hide the joint. Now I'll enable all the other parts, and at this point I'm done working in intermediate, so I'm going to jump back out to steps of completion. Now I'm going to do a joint between this and this right here. I'm going to flip it and drag it out here and click OK. Now, I'm not sure if this is making sense to you yet, but this is what we have done. This is a part that you make in a 3-axis CNC, which means that you need something to hold the stock, and you can only access features from one of the sides. So we start with a rough block, and the assumption with the rough block is it's not precise enough to hold it properly. So we start with the rough block and we make a couple of cuts on the sides and on the top. If you have a look, there's some material removed from the top compared to here, and that gives us precision faces to hold on to. Now we use those precision faces to hold on to it on the bottom, and we machine out our part. Now the part is also slightly lower than the surface of the top because we assume that that side is still rough. After we do that, we can't really machine all the way through because we have no ability to access what's behind the part. The bottom portion cannot be accessed. Furthermore, we still need material to just hold on to the part. Once we have done this side, we flip it around and machine off the back and get our final result. These are the different steps it takes before we have a fully finished part. And you need to be able to model all of the steps that your part is going to take. The reason we went about it like this instead of modeling it all out is because we wanted to maintain relationships. So I'm going to save this and show you what that means. So if I look at this part right now, let's say I don't want a sharp edge, I want a rounded corner. So I can fillet it here, 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 and type in 0.1 and click OK. And I can hit Command Save. Now if I wanted these changes to reflect here, if I didn't do it relationally, I would have to go change it here and here. But since I did it relationally, I just have to click on Update, and it's going to compute out all the changes. Give it a second. And it computed that this has changed to rounded corners, and this has changed to rounded corners as well. Another situation. This part assumes that you have a stock that is 5 by 6 by 3. Now the reality is, by the time you come to the center and actually find the piece that you can use, the size can change. And if the size changes and you don't have a relational model, what's going to happen is you will have to change this, you'll have to change this, and you'll have to change this. However, since we do have a relational model, we just have to come here, go to change parameters. You see these parameters are exposed, and all the files in the all the reference files that we have operate off of the principles of parametric modeling. So let's say I don't find a 3-inch stock, I find a 2-inch stock. It happens to be 4 inches by 3 inches, and I click OK. So this is the stock I found in the center. This is the size of the stock that I found in the center. Well, I hit save, click OK. Come here and I click update. Now I look at it from top down, and it turns out that this is very close to it's very close to the size of the part that I'm trying to make. That means I can't take away material from here. So I can quickly decide that this stock is not the right size stock for me. So I can be smaller in Y, but I need to be longer in X. So I come back, I change parameters, I go for something that is, I find something that's 4.5, but it's only 2.5. And I click OK. And we're going to see the effects of those modifications right here. So as you can see, the stock size modifications that we made are quite useful here, as they are able to accommodate the part that we have. We might even be able to get away with something that's smaller in Z. So I can look for another sock, and it happens to be 1.75, and I can click OK, save here, and come back to steps of completion, click on update, and it automatically updates. Now the height of this thing is highly dependent on the vise I'm going to use and how much area does it need to grip. So if you know how much area it needs to grip, let's say it needs only 0.1, so we can go for side height of 0.2. Click OK, and that changes the height of this thing right here. And all I have to do is hit save, click OK, and update the models here. So that makes that shoulder a lot smaller. Now let's look at some of the other parameters. Side removal and top removal, this all depends on the roughness of a stock. So if the stock is pretty precise, we don't have to remove too much material, and we can go with small amounts of material. So I'm going to click OK, hit save, and there we go. So we get the final rendition right here, and all those have been updated. Now this will also work with your part changing. So in the future you decide that you don't want these chamfers, you hit delete, save, and now you don't have to redo your part. All you have to do is click update, and automatically those chamfers disappear. This is the important key aspect that I want everyone to take home. You should be creating CAD models in a manner that they are usable with changes in mind. And that is the key takeaway from this lecture. Thank you.